Mark, welcome back to the program. Bonsoir, comment vas-tu?
Bonsoir, I'm doing very well. Thank you very much again for having me with you. It's always a great pleasure.
Very good. So Joe Castello, you are in charge.
Thank you very much, Francis. Thank you very much, Judy. Good afternoon or good morning or good evening, depending on where you are watching from. My name is Joe Castello. It is always an honor to be a part of the EPARTRADE Industry Week. Mark, how are you doing today?
I'm very good. No, thank you very much. I hope you're doing good as well.
Oh, I am doing fantastic. And just learning so much about a lot of the great products and a lot of the great businesses out there in our motorsports industry world. So what do you have for us this year?
I do have, again, coatings. You know, it's what I'm doing now for the past too long, probably the last 2 decades. So I bring with me a new presentation. I hope you can actually see it.
Yes, I can see it. And I got to tell you, I'm very excited about this one. Last year, you blew our minds with some of the possibilities for coatings. But this year, you know, DLC coatings on elastomers, right? Like something flexible like an O-ring. I didn't know that that was even possible. So you're going to be really making some new ground here this year.
Yeah, exactly. So, you know, this one. So I'm just going to go a few slides, but obviously the idea is really much more to have all your questions and you know, listen and etc. So just, you know, I need to do it anyway. So I'm going to show quickly a few words about the company. You know, Oerlikon is a big group. It's a Swiss group, and we don't do only chocolate in Switzerland. We also, you know, develop coatings and surface solutions. The good things about Oerlikon is that today, many people call us, you know, the one-stop solution when we talk about surface solution and coatings and etc. And today in Oerlikon, we got these 3 brands, Oerlikon Metco, Oerlikon AM, and Oerlikon Balzers. So AM, it's really everything about the additive manufacturing, you know, the 3D printing with a big knowledge about metallic printing. Metco, it's all about the thermospray, including a very well-known application for cylinder bore, which is a sumibore solution. And Oerlikon Balzers at the end, which is all about thin film coating made under vacuum. You know, last time I talked about it, but I always want to refresh quickly. When we talk about coating in our case, we talk about very thin coating. So we are talking about 3 micrometer thick coating. And very often the reason why we use this kind of coating is for the very typical topic, you know, reduce the friction, reduce the wear, overall improve the global performances of a system. It could be on the engine or other parts. We will see that later, or simply because we want to increase, you know, the durability and the lifetime of the parts. How can we do that? 3 micrometer, very, very ultra thin coating, but we bring a very high hardness, a very low friction coefficient. It is a clean process. You know, there is all this discussion about sustainability and etc. Thin film coating or actually clean coating. They don't have any, you know, poisonous reject or anything. So, you know, we are covering a lot of different things with our solutions. In order to do that, when we talk about coating, you know, many people are thinking about paint. It is, you know, very often the idea. Our coating are made under vacuum inside a chamber, and we have different processes to apply the coating. We have the PVD coating that stands for physical vapor deposition, meaning that we will have a physical target of the material that we want to evaporate and the coating we want to make. So if we want to do, for example, chromium nitride coating, we will use physical target of chromium. And you know, this different process, vacuum, all the parts will be under with the rotation. It will be made at different temperature depending on the process, but at the end it will give us very high hardness, very dense coating to prevent the wear and etc. The other process that we use to apply now a very well-known solution, which is called DLC coating, so diamond-like carbon coating. We use a slightly different system. In this case, we will use only gaze environment to apply the DLC. And this is why the DLC very often is made at a lower temperature. So here, that was just, very quick, just to remind you a little bit about the coating and the process. But I don't want to bore you too much with this kind of thing. The only thing that I really want the people to keep in mind, DLC is not one coating. It's a very wide range, very big family of coating. And depending on the process and depending on the technology, you can have completely different properties on the coating. But it's true that when we talk about coating like DLC, we are thinking about friction reduction and wear resistance. And the good thing is Oerlikon today can provide all the different technology and different kind of DLC you can find. So, the title of the presentation today is coating on metallic parts and more. But when we talk about metallic parts, if I look on the Valvetrain, this is where we have, most of our application at the moment. You can see here a quick range of all the parts that we can coat. So, this is what I discussed last year, giving some example. But it's true that today, parts like camshaft, flat lifter, bucket tappets, roller lifter, piston pin, these are now very common parts that you can find in almost all engines at the moment, and whatever the series, whatever the level, to be honest. And when we are on the top part of the engine, we will look about the DLC, mainly to reduce the friction. If we talk about the valve, we will look more about tougher coating that can resist to really high temperature. And if you go down, we are again back to friction reduction on the piston, could be also on the piston ring. So on the Valvetrain, many parts are today coated. And I remember 20 years ago, there were a project in France and the OEM wanted to make, the black engine. So 20 years ago, they shipped us all the parts from the Valvetrain to be coated. But it was more, for the communication than really any engine testing. It appeared that now it is actually the case. Almost all the parts now into the Valvetrain are coated. So it is great for us, but it also shows how the coating now is a necessity for the new rules and what we are asking to do to the new engine. So Valvetrain is one of our biggest applications, but we do have also a lot of application inside the gear train where we can coat a lot of different parts, the gears themselves, but also, the shaft, the selector fork. But again, we steal a lot into metallic parts and substrate. Other application that we face a lot is all about the suspension. It could be the rear suspension or the front suspension. And here, in many applications, we actually apply the coating on top of the existing hard chromium that you have already on this kind of parts. And again, overall, on all these steel parts, the main topic is reducing the friction and reducing the wear. So here, I wanted to go really fast because I think now it's something which is very well known and used. And of course, there is always questions, but it's true that it's now something very common. But when you look into an engine, in fact, there is not only metallic parts. There is a lot more things. And as you mentioned, Joe, before, you find a lot of elastomer and O-rings and other parts that has also a lot of wear and a lot of friction. So a couple of years back, we did the acquisition of a company who has a very interesting technology, which is, again, a DLC coating. But when we look to the properties of this coating, it was really incredible because first, the hardness, so this balinic millubia, the hardness of the coating itself is really, really high, much higher than any other DLC that we can apply at the moment. Well, that was not, the main interest. The biggest interest that we found into this coating and this technology is that we could apply the coating on almost everything. Or at least, when I mean everything, is at least a lot of non-conductive substrate that we could not easily coat in the past. So it's true that today with this solution, we can apply the coating on different carbide surface, silicon carbide or etc. We can apply the coating in different ceramic, alumina, other parts. We can also even apply the coating on PIC. But at the time, we really thought about, can we do something else? Can we apply the coating on elastomer? So when we thought about it, the first question were, okay, if we had to coat an elastomer, what could be, the blocking point in putting a coating on this kind of substrate? So first, it is a non-conductive substrate, but with millubia, we cannot have an answer. The other thing is, as I said at the very beginning, most of the coating are made at pretty high temperature, 250 degrees and higher. And if you want to coat elastomer, that might be an issue. One of the key points of the millubia coating, it is made at very low temperature. It's actually made below 100 degrees C. We even measure coating around 80 degrees C. So, non-conductive substrate, very low temperature, and we can do from a few nanometers to a couple of micrometers. And today, when you say all that, we are not talking about a very small R&D chamber. We are talking about definitely an industrial process where we get a chamber which is up to 1 meter height for the production. So it's definitely, production oriented is not an R&D thing, at least for the coating. So we had everything, in hand to be able to develop the new solution. So what we did at the time is that we say, okay, we cannot start running around and ask everybody we know if we can coat some parts with our solution. So what we did, we went to Valvetrain in France, who had a lot of experience on elastomer, and they had specific tribometer and etc. And we asked them, can we measure the benefit of the coating onto your tribometer? So what we did, we just coat, very small parts of elastomers, very basic, NBR2 that you can find on many applications. And what we saw immediately, so the gray part is the pin that you see here against the elastomer uncoated. So you can see that the friction is definitely not great, I would say. It's still really high. And we were actually very surprised to see that as soon as we applied the sample with the millubia coating on it, we dramatically reduced the friction. So, that was our first, lesson. Okay, friction can be reduced. But then, if you look to the parameter of the test, we were, okay, my colleague who actually supervised the test told me that he almost fell asleep when he was looking to the pin sliding. It was so slow that, it was absolutely not linked to the application or the reality that we are facing in motorsports. So we were, okay, we need to make our own test. So we came back to the office, we worked on our tribometer, and we replicate actually exactly the same thing that we saw before. So we could see that without the coating, we had a friction around, 1 in terms of friction coefficient. And with the Melubia coating, we were below 0.2. And from our point of view, it's actually, a massive improvement. So we were able to reproduce, on the lab, a very low friction on an elastomer. And for us, that was a big step forward. But that was only, the first step. So what we did at the time, I reached out to a couple of friends that I know into the motorsports industry, and I say, look, I got an idea. We are talking about elastomer. We have a lot of experience when we talk about suspensions. Can we coat the seal, the inside, of the lip of the seal, instead of coating the suspension tube itself? So at the beginning, my friend really thought that I was completely crazy because, when I told him a very hard coating on the elastomer, what about, the flexibility and etc. So he was really not convinced, but he gave me a few parts because, this is the joy of motorsports. If you don't try new things and extreme things, you never move forward. So he said, okay, let's go and make a test. So what we did, we coat the inside lip, of the seal. And when he put everything on his bench, basically, this is the kind of result he had. This is what he saw and what he measured at the time. So 36% in terms of friction reduction. So we made the other test that he used the standard seal, but the coating on the tube. And we had almost exactly the same result. But the only thing is, a tube is something around 600 millimeter long, while a seal, it's more 50, 60 millimeter in diameter. So the part is definitely smaller. So potentially economically, for the same technical results, it could be much more, beneficial. And everybody today is looking for the best performances at the best cost. So, we were definitely convinced that there is something to do right now on elastomer with our new solution, which is in that case, the Melubia. And I got to say, right now, we are busy in testing a lot of things. A lot of seals, a lot of O-rings and etc., but many applications into a lot of different environments or lubricants, oil, or counterparts. So we're still learning, but we have a lot of things ongoing at the moment, to be honest. The good thing is, as I said, for the machine, as most of the application that we do, the idea is not to have this kind of product only for the track. We really want to push it also for the road and the bigger, volume in the future. But first, we know that in the coming months, coming year, I will say, our focus will be for the racing industry because we need to learn, we need to develop, we need to modify, we need to improve. But it's definitely a solution that we're going to push. And you might see very soon with many supplier and racing cars or bikes and etc. I get no doubt about that. So that's it for me. This is for the presentation. I really wanted to be really quick on the presentation itself. Now I really prefer to be, an open dialogue. Joe, if you get any questions, any feedback, I hope it will be easy question, to be honest, if you get one. But let's see how it goes. And if anybody on the attendees also gets questions, I'm more than happy to get a stab at it.
Absolutely, and that's what the chat section is for. So for people around the world who have some questions for Mark, just put it up in the chat section. It's so intriguing to me that you're able to, DLC an elastomer like that, and does it change the properties of the elastomer at all? Does it retain all its flexibility, all of these things? Because it's just to be new ground.
Yeah, exactly. So, this is the thing, when we talk about all the metallic application, we are talking about very high thickness, 2-3 micrometer or even much thicker. If you do this kind of thickness on the elastomer parts, yes, you will definitely change some of the properties, especially, the elasticity and the flexibility of the parts. And this is why, for the moment, we've been focused only on the friction parts. And this is why, for the moment, we are applying something like 100 to 200 nanometers of coating. So it's almost nothing. And this way, we keep completely the way the parts are actually moving and working. So I don't know if you can see, on the screen. This is, small membranes, which is coated. And as you can see, I can actually twist it.
Let me interrupt you there for a second, Mark,
Sure.
just because your screen is still shared on your presentation, which means
So
I
I'm gonna
are small.
Okay.
That's what I'm seeing. So now
I'm going to stop sharing. So
now
basically,
show it again. There you go.
So, you can see that membrane. So very thin membrane. As you can see, the color is slightly different. So it has been coated. And as you can see, I can definitely twist it in all the way around and put it back into one piece. So here, again, it's really linked to the fact that the coating is really thin, but the adhesion is really good. The thing is, if you look to the parts under a microscope, you will see that actually the coating is fully cracked. But this is the beauty of the solution, that if you stretch, the parts, you can see that all these small islands, between the different cracks will actually follow the elastomer. And when you unleash, basically, it will all come back all together. So the coating will crack, but it doesn't mean that we're going to lose the adhesion of the coating on the part itself. So, I can see in your eyes that.
Well, I am, because I'm thinking about it. I'm visualizing what you just described, which is, it's a certain size, and then when you coat it and then you stretch it, and there's going to be cracks. I think of a desert, like a dry desert.
Exactly.
And then it comes back together. It still does what it needs to do. It's not like it flakes off, or so that it's just intriguing, but it is a little bit of a mind freak.
So, I was actually earlier this week with a customer, and then we were working on the suspension, and they are really doing a lot of tests at the moment with different speed, different loads, different displacements. So I got to be honest, we're still a little bit on the learning phase, no doubt, because I'm also realistic. As I said, 20 years into the motorsports industry, and even 2 years ago, I had no idea we can actually do that. So, COVID and etc. did not help at the time. But when we really, put a stab on the topic, and we start learning, and we are building a lot of relationship with a lot of people at the moment on that topic, we are definitely learning. So much more to do. We are on the beginning, not of this coating, but we are on the beginning of this combination, putting a very hard, ultra thin coating onto an elastomer to reduce the friction. And the second step will be to measure the durability and can we extend the lifetime of this kind of parts.
Excellent. We do have a question from Thomas out there, and other questions are welcome, and I'm just going to hit you with them, Mark. Thomas wants to know, have you used the coating for aerospace applications, valve, actuators, etc.? Definitely.
I mean, today, in Oerlikon, we got a lot of different segments. So motorsports is one of them, but we got a lot of application in the aerospace industry, either as a replacement of the hard chromium, or simply because we want to reduce, fretting issue or wear. So it's definitely developing into the aerospace, and both into what we call the frame, which will be somehow, the chassis of the whole plane. But also we are developing very specific solution for the turbine and for the engine in aerospace. So many small applications in aerospace in general, but aerospace, is a big topic. It could be from the hydraulic system, it could be from the frame, it could be from the engine. But yes, we do have application in general for the coating. The one I'm talking about on the elastomer, not yet, but we can see already some interest coming from that segment.
Excellent, excellent. Typical coating temperature for DLCs. What is that? Like, what is the operating temp?
So overall, DLC normally is around 300 degrees C. And this is why here with that solution is a big revolution, because we are below 80 degrees C again. So this is why big difference. And this is why also we are capable of applying it on this kind of substrate. But yeah, typical temperature is around 250, 300 degrees C. And here in this case, 80 degrees C.
Excellent, excellent. If you've got a question, and please put it in the chat section. So what I'm thinking about, Mark, is it's got to be very interesting for you to be in a space that is undefined and you're still learning like what's possible. And, why don't you list some of the applications that you've already gone down the road? Because I wonder, are other people starting to spark some ideas on like where might else this be used? If you follow what I'm saying, if you're just learning, like I'm sure it's a wide open landscape of possibility when you're thinking about reducing friction and obviously protecting something with the DLC.
So yes, we are definitely learning, and then as it is new, we cannot also chase all the rabbits out there. So right now we have a strong focus on the seal ring. As I said, for the suspension and etc. But we do have also some application where we code so in that case we code the inside of the seal. So the inner lip. That will actually do the sealing, and where you will find all the friction on the different shafts and etc. So here, many application ongoing on that case. And other application that we are looking at is applying the coating on the outside diameter of an O-ring, for example. So learning definitely, yeah, as you said, very interesting, because we are almost starting from scratch. And like 20 years ago with the DLC on steel parts, a lot of people are, how can I say, they're not really sure if it's going to work or not. But the industry is also different now. There is a bit more knowledge about the coating than 20 years ago. So the people now, if we come up with a new solution and already some data, as I've shown, they are more inclined to actually test and give us feedback. So definitely a whole world to discover, but very interesting.
Excellent. Jim is out there with a question. Jim, thank you for your question. And anyone else out there who's as intrigued as I am, please put your questions in the chat section there. Jim asks, are there any limitations about the material or geometries, etc.? And then same question about roughness, if you could attack that, Mark.
These are great questions. About the material, I think the issue with elastomer is that the possibility or 1,000 times bigger than actually in the steel industry, with metallic parts. And today it is a big question mark. We have coated a lot of different NBR or FKM substrates that you can find typically for the steel, but we don't know the limitation about everything, in terms of what kind of adjuvant, additive could be put into the compound for the color, for the hardness, for everything. We don't know yet how it could impact the coating performances or adhesion. So we are learning, but we do have a couple of good things that we know now. As I said, nitril, NBR, and all. So far, we had pretty good results. In terms of the geometry, coating the outside of a ring will be very easy, like any other parts. Coating on the outside of the part, it's kind of easy, I would say. But when we start talking about the inner diameter of a ring, it's a bit more complex, but so far we have been able to coat everything we receive. And we receive ring from 5 millimeter of diameter up to almost 100 millimeter of diameter. So again, we are learning, but with the technology and the fact that the ring, it's a pretty small part, we have almost succeeded every time. The fixturing is a bit of a challenge all the time, but it's also what makes fun this new application. And about the roughness, if we are talking about the roughness of the part itself, today we never really face any issue because roughness-wise always very low for this kind of application. And the coating, once you apply on top, as we are talking about few nanometers of coating, you do not change the roughness, the quality of the surface of the parts.
Interesting. And thank you, Jim. Thank you for your question. Mark, let's take a moment to delve into the mechanism of how this all works for someone out there who is interested or intrigued in going through this process and getting their stuff coated. Like, what's the action step to find out more, and how long does the process take? Walk us through that whole deal, because I think that this is people with shops or people who are working on R&D right now are thinking, okay, this sounds intriguing, but how does the process work of actually getting parts to you and getting them back and all of that?
So I would say like any other application. So either you get in touch with me directly, personally, and I can redirect to a local contact, either in the US or the rest of the Europe. For that point, it's pretty easy. What we need all the time is at least, at very minimum, picture of the parts or even drawing of the parts. It's even better. Knowing the composition of the parts, where do we need to apply the coating? And is there any masking that we should apply? These are the minimum information that we need to get, the drawing, where we need the coating, the material, because as I say, we were learning about that, and how many parts you're looking for. If it's only 2, or if it's 200 or 1,000 parts, it's always interesting to know. Once we have this kind of information, we will look how we can place the parts inside the coating chamber, taking into account the area where we want to coat and all. And once we have all that, we can give you a price for sure. And then for the coating, at the moment, everything is done in our factory in Finland. But we are definitely looking forward to get this kind of technology in the US and in other locations in Europe in the coming years. Turnaround time, it's very busy right now, I gotta say. But if I say that we are around 3 weeks to 4 weeks right now, it is kind of the time frame that we have. So yes, it's really long for a motorsports application, but we still definitely learning. And the target that in the future, it's going to be definitely faster. But there is nothing, special in the process between a metallic parts or an elastomer. The overall process is very similar, except the time frame, which might be longer for elastomer at the moment.
Excellent. Now, you just referenced you're looking to expand where the process is done, potentially into the United States. Is that something that you want to touch on a little bit? I know it's future focused, but it is also growth focused, and that'll enable you to do more.
Clear. Thank you for that. I mean, we have already several locations in the US where we do coatings and specifically coating for the motorsports industry. So definitely that machine will end up into one of these locations, but as everything, as we're still on the learning phase, we are really targeting some key applications. And as soon as we will find, concrete results and things that can definitely justify the investment into a brand new machine, of course, we will do it. And the thing that I need to mention is that building a coating machine is not something that you do overnight. So it will take several months to get that. So this is why between having the very first sampling done in Finland, running the test, and if you said, yes, it works, I want it, we might have to run the production in Finland for a while. But it's okay. We definitely have a plan. If I want to be very optimistic, I would say that having that kind of technology N23 will be, the great idea. If I want to be realistic, I would say more mid-24, but it's definitely coming.
Excellent. It's amazing to watch this technology move forward. And again, if you've got a question out there for Mark, put it in the chat section. Got a couple of more minutes to go here this hour. And Mark, what surprises you about this? Being able to work with something that is a cutting edge technology that, and I keep going back to your initial comment, like we're still learning, right? What's possible with this? What can we do with this? This is amazing. Let's try this. That doesn't happen all the time where you've got something that keeps on giving to you. What has been so surprising to you about this technology and the way you can apply it?
The very first time that I heard about the coating, I was, okay, it's another DLC, why not? But, we did not know much about the kind of application. And it was one of my colleagues who really looked deeper and deeper, especially him, and he started to pull out all the potential application and substrate. So then suddenly we were, okay, let's think into our different activity, what kind of application we can coat. So we went through a complete, big brainstorming, definitely crazy idea. And then we say, okay, we still have to be realistic. What are the real application we can coat? And in motorsports, it's true that in industrial in general, all the O-rings and sealing rings came out very quickly, So that was the very first idea. Then we said, but can we really do it? So we have started just to apply the coating on very small samples, flat elastomers, just to see, can we actually put the coating on it? Then we moved to the ring, to the real part, then we made the test. So, everything we've been doing, it's already something that we do now in several months, almost a year, that we really started to look about coating on elastomer. But now we were at the point where we said, we can actually offer something now to customers, not only from the laboratory, we really want to move on to parts. And I gotta say, it is a different world. We are not talking to exactly the same person as usual. I don't have 20 years of experience behind me to explain to a customer what could be the benefit on the ring. But as you said, very interesting, challenging, learning every day. And I'm sure that more application and question will come up in the coming months, to be honest.
Yeah, but that's what makes it exciting. And to be able to be on a cutting edge of anything is awesome. And you must, love going to work. Bill just checked in. He's coming in late. He apologizes. And if we have discussed this or not, but can you elaborate on the difference and or similarities between DLC and PVD?
So it's a very, it's a very common question, and thank you for asking it. First, DLC is a family of coating. PVD is a technology. So, it sounds natural when I say that, but a PVD is a technology how to apply the coating. So very often, we mention, oh yes, we do a PVD coating. Okay, which one? Which kind of coating? A chromium nitride is made via PVD. A titanium nitride, this gold coating is made with the PVD technology. So many coating can be applied with the PVD technology, while the DLC is a coating itself. So it is the first big difference. When I look to the DLC in general, it's really when we have the target to reduce friction and wear. That will be the prime request, reduce the friction. DLC is what we call a carbon-based solution, and we use it mainly to reduce the friction. When we look to many other coating made with the PVD technology, normally friction is not the best point. It's going to be more temperature resistance, very high hardness, which be also wear protection. But the idea is really about the temperature. A DLC coating can work up to, let's say, 400 degrees C. After that, it's no good anymore. It will come back to graphite again. And this is why then we use coating applied with the PVD technology that can resist up to 1000 degrees C. So here, I hope the answer is okay. DLC is a coating family, PVD is a technology, how to apply coating.
Excellent. And what is it? Physical vapor
Deposition.
deposition.
Very good.
Yeah.
So you see, coating
Right off the top of my head, Mark.
Easy. Coating is in fact something very easy, and there is nothing special to know about it, to be honest.
Yeah, but this give us a little history. This technology has made a tremendous difference. I can say, speaking from drag racing, like hearing about coatings, whether we're talking about pistons or rings or otherwise, right? Like this has been the driver of a lot of performance, but also endurance, right? It enables the parts to last longer, and you might spend more having something coated, but it's going to last 4 times as long, and there's a cost balance there that ends up working out. When did this wave start? When did this wave of coatings and this technology really catch fire and get legs?
So it started before me, obviously. I'm not that old. I'm getting older and older, but I'm not that old anymore. But I remember the very first part, DLC coated in motorsports, at least that we have coated, it was in 95, so 1995. And at the time, that was I can mention that was for Peugeot Sports when they entered the Formula One at that time. And, the 10 years after that, the interest of the DLC was really about the friction reduction, how to get more power by reducing the friction. And at that time, that was, from my point of view, somehow the golden age of motorsports, because if you look to Formula One, we were at the end of the V12, we still into the V10, part, no regulation about how many races an engine should do. So it was all about the performances. And, suddenly we started to downsize the engine down in Formula One to the V6 engine now, turbo V6 engine. But now one engine should do not only the qualifying, they should run for at least 5 weekends of race. So, the coating came from purely friction reduction performances to today performances plus durability. And this is really the whole thing about the DLC, that it's not only about the friction reduction. The lifetime is also key. We have many series where the engine are built at the very beginning of the season, and then they are sealed. And if you actually open the engine to check whatever, you might lose points. Having the DLC on some key parts actually prevent you to get any wear, any issue, and make you last the whole season without any trouble. So the DLC now is really, this is the solution that we can offer is really about friction reduction, reliability, and performances. Excellent. And all of those things are high on the list of desires from anyone involved in high performance.
I agree. Yeah. I mean, I remember, 10, 15 years ago,
one of the big engine responsible in Formula One at the time, say, look, without your coatings, our engine cannot run. So, you know, I was kind of impressed about this kind of comment, but actually it's really true.
Well, to operate in certain ranges, and that's why so many are involved in motor racing, is to watch the technology advance. Things that were impossible a couple of years ago are now possible because of a new technology. And then all of a sudden, you've got to go back and rethink everything that you tried in the past, right? Will it work now?
It will. You know, the thing is, and it's one of the things that we see. When we started with our coating, it was really only about the motorsports and the racing industry, you know, the performances, somehow small, medium volume. And year after year, it's moved to the road application, you know. So today, there is a lot of DLC coating application into a passenger car. You know, the piston pin is a very standard things, piston rings, needle injector, all these kind of things are now DLC coated on the OEM level, on 2 wheels or 4 wheels. When I look to what we are doing on the elastomer, I have to say that some of the original requests that we had was first from the OEMs and immediately asking us for solution for a couple of million parts per year.
Wow.
So, you know, suddenly the interest switched a little bit, that the racing in the past was the one pushing new technology to the road vehicle. This time that was actually, you know, the passenger car, we had the biggest interest. But before going to passenger, we said we need to prove that it's working. And the easiest way and the fastest way to do that is to go on the track. So this is why we took the decision to say, we're going to prove it first, make it work, and then we will come back to you. Also because OEM people do not have really the same, you know, way to put the comma on the price. For example, I got to be honest, they are talking in mini cents, while today we don't know exactly the kind of range we can get. So we are learning, definitely learning.
Well, that's got to be great experience to go through as you're pushing it forward, right? Pushing the technology forward,
Yep.
going to new places. Mark, once again, why don't you give the contact information for folks out there that are interested so they can reach out to you directly or learn more on their own, you know, go down the rabbit hole and start reading. That presentation was tremendous. But and people will be invited to watch it again here on EPARTRADE. Of course, these things are going to be released and live forever in these on the web. But give that hardcore information for people to reach out to you, and hopefully they will be reaching out.
So I can do that now. Actually, if you want to work, that's it. You got my email address on it, and you can, you know, go to the website anytime. And yeah, I mean, I will be more than happy to answer whatever kind of question I can get. And if I'm not the one having the answer, I will definitely do everything I can to find the right person to give me the answer. But yeah, you can drop me an email, and then I will have a look. No worry at all.
Is there anything that we did not cover that we should have? Is there a question that wasn't asked that should have been asked, or something that we should go a little more deeply in our final couple of moments?
It might be a stupid thing, but the coating gives a color to the parts. You know, DLC coating in general, when we are on a 2 to 3 micrometer thick coating, they are black. The coating that we are doing right now on the elastomer is much thinner. So it gives more some kind of a metallic rainbow color, you know, on the surface. But it's just to say that for the part that we are coating so far, if you get I don't know, a red ring, a red seal, it won't be red after the coating anymore. So it might be stupid as a feedback, but don't expect to have a completely, transparent solution.
No, that's a great note. That is a great note for those that are choosing the color of the product over the durability of the product. They need to.
Exactly.
Mark, thank you. I see Judy, I see Francisque are back, but an amazing presentation. I love doing this with you because it's just so eye-opening into the razor's edge technology that you're working with. And thank you for spending the time today.
Oh, thank you very much.
Thank you very much, Mark. Great presentation, a brilliant company, Oerlikon. We just pushed Oerlikon's product back on the homepage of the EPARTRADE platform. So please go to EPARTRADE. You can see all the great suppliers like Oerlikon showcasing there, as well as the schedule and all the speakers for Race Industry Week. It's very important for us to bring you not only the greatest series organizer, the greatest promoter, the greatest of everything this week, but also some of the greatest suppliers out there that are really expert and have an expertise in the very specific area. So thank you, Mark, for your time today.
Registering on EPARTRADE is easy. To start, click on the Join for Free button on the homepage. First, search your company to see if it's already in our database. If you see your company on the list, click on it to select it. Then, choose Claim Company if you are one of the decision makers, an owner, marketing person, or main company contact. Or choose Join Company if you are an employee, and press Continue. If you couldn't find your company in our database, select Register a New Company. On the following page, fill out your name, email, phone number, job title, and choose a secure password. If you chose Register a New Company, you'll need to choose your business type. Select Supplier if you're looking to display products or services and connect with buyers. Choose Racing Business if you're looking to source new parts and connect with suppliers. Choose Race Team if you own or are a member of a professional race team. Then, enter your company name. Please provide a website, Facebook page, or LinkedIn if you have one, and choose to either claim or join the company. You can view and agree to our terms of use here. If you'd like to receive our weekly newsletter, choose Accept. Finally, click Register Now and your registration will be submitted for approval. An email will be sent to your inbox. Please confirm your email address and you will be approved shortly. Welcome to EPARTRADE.